repetition, we're going to need to go over Tuesday's project, which was to make a what's it called? A sorting algorithm in Java. So how many of you guys were able to do the sorting algorithm? Like, does anyone have any questions on it? Does anyone?
You should first ask if anybody did it.
Yeah, did anyone do it, I guess, is the first question.
Because I suspect that everybody wants to see your answer and that nobody really did it.
So, I mean, has anyone done it, and is anyone willing to, and if you did, would you be willing to share your code before we show our answer?
And there, I think, is your answer. Cricket.
So it looks like no one did.
I did it.
Yay!
Awesome.
Who
Can you share
is
your
the
code?
speaking?
Yeah.
We are really impressed. If I had a gold star, I would give you a gold star right now.
So, would you like to share your code? Here, so what's your name? Is it Anushka? Is that your name? So, okay, if no one's gonna speak up, then I guess we'll just walk you through it. So, I mean, sorting algorithms are a big part of programming. We do a lot of sorting. Sorting algorithms are like a well-known challenge, if you will. There's a lot of different people working on sorting algorithms. There's a bunch of different well-known sorting algorithms, and a lot of people even like dedicate a big portion of their lives to finding better ones. Like, there's people that do their entire PhD on these types of algorithms. So, I mean, obviously, sorting algorithms are a really big and important part of the code that runs every day. But here we're just going to do a basic version of that code. So the challenge was to sort an array and put it in alphabetical order. So in order to do that, I mean, in numerical order, so we're going to create an array. So int array my array is, and we're just going to put a bunch of random numbers in it. So 1, 2, 503, 314, 1678, 254, 67, 27, and 1023, and I don't know, 900. So we just have a bunch of random numbers in any order in this array, my array. So what we need to do is we need to get this sorted into a list and make sure it's all in numerical order. So what we're going to do is, let me just admit. Okay. So what we need to do is we're going to first have a for loop. So this is a standard for loop. For int I equals 0, I less than my array dot length, and I plus plus. So what this is going to do is this is going to loop over every single number in our array. Right. So what we want to do now is we want to be able to sort we want to be able to get these in the correct order. So one way of doing this is if you pick a number, is if you go through and you figure out what's your lowest number and then bring that to the front, right? And then you ignore that, then you bring your next lowest number, you take your next lowest number, and you take your next number. So say we start at 1, we find the lowest number, which is 1, and then we bring that to the front. Then we take our next number, we look through our entire list, find the next lowest number, and that would be 27. We swap the positions. Then we go to the next number, and so on. And by the time you get to the last number, you're going to be fully sorted. So how we do this is we want to pick an initial number. So we're going to say int. So we're going to say int lowest position is equal to, and we're just going to pretend that we're going to start at I. And what we're going to do is we're going to have another for loop that'll go through and check all the remaining numbers. So int j, so for int j is equal to I plus 1, j less than my array dot length, and j plus plus. So what this is doing is we're going to pick a number, and then we're going to look at every number after it and see if there's anything that's lower, because we're wanting to sort this in increasing order. So since we know, right now we're pretending that our lowest number is the front, is the first one that we've selected, and then we'll go up from there. So what we're going to say is we're going to get if, and we're going to look at my array sub j is less than my array sub lowest position. So is less than my array sub lowest position. So that's what that's doing, is that's taking the current number that you've selected. So say we're starting at 1. If we start at the beginning, you're going to take 1 as your lowest, which is position 0. And then you're going to take the next number, which is 503. And then you're going to say, is 503 less than 1? If it is, then you're going to do something. Otherwise, you're just going to do nothing, because then you know it's already in order, right? So if it's not less than it, we don't want to change anything, so we're just going to leave it as is. But if it is smaller, like say 27 is smaller than 503, okay, right? If it is smaller, then we want to note it down and say that, hey, that's our lowest number so far. So then we're going to say lowest position is equal to my array sub is equal to j, right? Because we're keeping track, lowest position is keeping track of the index. So if we say, look, so right now, once you go through this for loop, what you know is where you're starting, and then you know if there's any number afterwards that's actually lower than that number, right? So when you have a number that's lower, what you want to do is you want to swap it. But in Java, one thing, what you can't do is just say x equals y and y equals x. In Java, that's not going to work, because if you set x to y, you can't just setting y, then you just be setting y to itself. You won't actually swap it. So what you need to do is you need to create a temporary variable that will hold the value while you're in the process of swapping it. right? So we're gonna say int temp for temporary is equal to lowest position is equal to, sorry, my array sub lowest position, right? So you just got the smallest number you just put the smallest number and you put it into this temporary variable. So now that you know the smallest number, you know that your current number is bigger than that smallest number, right? So what you're going to do is you're going to say my array sub lowest position is equal to my array sub I, right? So the number you're looking at, the number at the lowest position, you know is smaller than your current number. So what you're going to do is you're just going to swap them. And if eventually, as you keep going, by swapping them, you'll get it in order. So once we have that, we can then put temp into the original position of my array sub I. So my array sub I, we're now going to set it equal to temp. Right? So through doing this, you're going to get my array into the correct sorted order. So now all we want to do is we want to print out. So we're just going to create another for loop for int I equals 0, I less than my array dot length, and I plus plus. We're just going to say system dot out dot println system.out.println, and we're going to say my array sub, okay, or we're just going to say my array sub I. And if I spell array right. Right, so now when we run this, we should get all these numbers in order. Let's try this. Yep, and you see all these numbers are now in order, right? So when you look at this problem, it looks really complicated. Like how the heck do I get all these numbers in order? But if you think about it and you slowly look at it logically, you can eventually figure out that, hey, I can do this, right? So I mean, initially it may look really complicated, but this entire thing was done in like 10 lines of code, the actual part of sorting this array, right? So this actually isn't that complicated at all. And so like, if you look at it now, you'll see, oh, it's actually quite simple. But the thing that you should understand is that in Java, the only way you're going to learn is by trying. If you just like look at it and give up, you're not going to get anywhere. So are there any questions on how, again, this isn't the only method, but are there any questions on how you can sort? Any questions? So does anyone want to share their code? And who said they did it? Like, can you raise your hand if you did?
I did it.
Okay. So would you like to share your code so everyone can see it? Awesome. So I'm going to make you a presenter. Okay, you should already be able to share actually. So I'm just going to stop sharing, and then at the bottom of your screen you should see a square with a rectangle with an up arrow to share. Are you able to share? Yep. So we are looking at your code.
So, yeah, I did this. Wait.
Okay. So you used an array list, that's fine.
Yeah.
So awesome. So it looks like you did something really similar, did you? Is that?
What?
Awesome. So you want to run your code or?
Awesome, it works. It swapped 5 and 102 into the correct order.
Okay. Should I
Yeah.
stop sharing now?
Yep. So just to show that that this is actually working, can you try adding another number?
Okay.
So you pick your favorite number, but yeah.
Okay. Wait.
Excellent.
Awesome. So yeah. So you
Excellent.
followed
Great
really
job.
method. Yeah. That's an excellent program.
Okay. Thank you.
Yeah. So did anyone else do it? Was anyone else able to complete it? Or was it just her?
Come on, guys. Participation is crucial for these kind of things.
Don't be afraid. I mean, if you're too scared to share now, it's going to be really tough when you're actually writing code for your robot. So no one else. So what I'm hearing is no one else actually went through and did the code. Is that
That's how I'd interpret it.
okay? So you have one person who participated.
All right, well, that's a downer. I mean, what we have in store right now is we were going to present to you guys the competition challenge that's kind of going to be like the highlight of, or like not the highlight, like your main evaluation of your own learning throughout this course. So we'll be presenting that idea to you today. I'm just really hoping that, especially gauging off of this, I'm really hoping that that will get a little bit more participation, because we're going to have a little bit of a competitive aspect to it. And it also is something that we usually go, it's made for if you guys are interested in joining our programming group on the FRC team. Like this will be a decent way of seeing like where you guys are amongst your skill levels in the programming, and if you guys are following along. So if you want to be on the programming group, it's really important that you participate in that event. Otherwise, it's not going to look good for you. So, I mean, Sai, if we're not going to take any more volunteers, is it okay if I just present the project?
Yep. So I guess last call for volunteers in 3, 2, 1. Okay, looks like we have no one. So Josh, take it away.
All right. I'm going to go ahead and share my screen. All right, can everyone see this?
Yeah, we can see it.
Yep. Okay. So the base idea of your project is that you are basically the owner of your restaurant, and you're creating basically a program that can register families, like groups of people that would sit at a table. That's basically what we're calling a family. There isn't really a necessity that people have to be related to each other. So we're leaving those kind of details kind of vague. But the concept, or before I explain the story, is basically we made all of this code to follow along a certain story. And because we are really bad coders, we made so many mistakes. Like, look at this. Wow. So, and not even just in there. Like, look at, what is this? Come on. Okay, so basically what I'm trying to say here is the goal is for you guys to detect as many errors as possible. And in the comp sci class, they kind of explain this in a pretty nice way. There are 3 types of errors that you look out for, and I'm sorry that I don't write it down anywhere here, so you might want to just, it's pretty easy to remember, but there are 3 types of errors. You'll have syntax errors, runtime errors, and you'll have logic errors. Okay, now I'll tell you 2 of those are a lot easier to detect than the others, right? Whenever you click the red run button, you see that there's clearly an error in your program, right? That sort of error is as in like the code can't run because there's something broken with it, right? So my code is broken here because there are red squiggly lines underneath it. So as soon as you see something that has red squiggly lines, you know for sure that there's a syntax error there. Okay, runtime errors, on the other hand, I'll tell you right now, there won't be any runtime errors as for this challenge, just because Rappel has a really weird system of preventing all of them in the form of syntax errors themselves. So you're really going to have just 2 categories. You're going to have the syntax errors and logic errors. So syntax are the ones that are blatant. They'll give you a red squiggly line, or they'll tell you in the console that your program is flawed, like in terms of Java language, right? But then the logic error, that's just something that you have to understand in context to the problem that we're going to explain to you. So if there's something along your program that's flawed, like logistically, right? Like there's supposed to be a method that tells you 1 + 1 is 2, but for some reason there's like some missing order of operations that says 1 + 1 = 503 for some reason, right? That's an example of a logic error. So the program won't ever tell you that there's an error there. You have to be able to find it yourself. To be honest, though, it's still a very easy thing to find out, because you're going to be given the variability of creating your own test cases. And once you see like your test cases are flawed or whatever, like the output is incorrect, you know that there's a logic error. All right. So yes, now I'm going to explain the actual story of the problem. And yeah, this session is being recorded, so like we didn't need to document the exact story of the problem. It's quite simple, so just watch the recording for anyone who's missing out on this. So basically, you're the owner of a restaurant. You're creating a program such that multiple groups of people can come in and register themselves in this array list of families. Every single family is constituted of its family members, which are basically just names, the ages of each of those people with the exact order put in here. So like if I have John, Macy, Max, right? And I do 5, 8, 9, then I know John is 5 years old and Amy is, I forgot the numbers I said, but all you have to know is it's in the exact respective order of both of these arrays. Okay, so yeah, that's the idea of a family. So once you, as you can see, it does look quite messy here, but all you have to understand is this is just adding multiple families. These are your test cases. You can add more to them, but these are like the ideal test cases that are given to you, and we'll show you why in a second here. Okay, so names, ages. And then another thing that you can add here is you can specify whether a family has like a veteran, like a military veteran or whatever. And the reason that you can specify that is because like you can get a discount on their prices accordingly. So the 2 conditions there are to actually get a discount are if the family contains a veteran or if the family contains a senior. And you'll see that the requisite for being a senior is just older than 60 years old. Okay. So now the idea of this, right, you should already know about array lists. So when I'm saying families.get0, and it's okay that I'm explaining a little bit of this, I want you to at least be able to read the code by itself. So when I'm saying families.get0, I'm getting the first family of the entire array. The order of the families themselves don't matter. It's just consider it family 0. Okay, and these adding orders, these are just like adding items to the purchase list that this family is getting from your restaurant or whatever. Okay, so each of these families have their own order. These are like order numbers, right? Like when you're saying you want a specific item on the menu, so this will access specific the specific items on the menu and actually add them. So these numbers on the right here, they're not meaningless. They actually have that sort of value. Just for like conventional purposes, because this is supposed to be a very simple program, we didn't want to do anything too complicated. But in a real world problem, this would probably be a really good application for enums, so that you could like embed numbers behind true like words. So that probably would have been the ideal case, just to let you know why we didn't use it there. All right, and then yeah, so the basic logic of it is that once it's registered, like what orders are there for the entire family, it should be able to print a receipt that basically just gives a good summary of all the details that there are. And you can go ahead and read this yourself, but it's just going to be like all the item names that you bought, the prices that correspond to each item, then your total price for the items themselves. And then, so don't confuse total price with their overall price, because you still need to apply the discount, the type of, and you need to specify the type of discount, and then obviously like the federal, whatever state tax, and then your final cost. Your final cost is actually like the overarching cost that you have for the purchase. So a lot of the complicated, like bare bones of this stuff is honestly already there for you. So your only job is to find out what's missing in this program. Like this is just the overall format of the receipt. So that's just how it will be printed out. So make sure that just to give you a hint, this is probably the first place that you should look at for logical errors, right? Just go from here and then trace it back to whatever references are being called in over here. And that's where you'll be able to find out, oh, hey, this thing's not correct because it's supposed to have a negative sign in front of it or whatever. Okay. The family object, once again, this is just to contain all the attributes of your family, like get, budget, ages, whether it contains a veteran or not. So, all these methods, making sure you're following the principles of encapsulation. Now, the principles of encapsulation are actually not tested on in any of the problems, because technically your program still does function correctly, even if you don't follow those principles correctly. So don't worry too much about that. All the encapsulation principles are already being followed here, basically. Okay, so add order. Lastly, this you do not want to have to worry about at all. So don't think like there are any errors here. Once again, if you see something that you know for sure you haven't learned yet, or it just looks very like super unrecognizable, right? Then it's not something. It's definitely not something that you're going to be tested on. So like this, for example, this to array method, you've never seen those words probably in your life with context to array lists, then you don't need to worry about it. This is just something that we have in the backbone of the code. So that's why we're more worrying about you fixing actual errors. Okay, this is the menu. This just contains all the items, corresponding prices. If you have had a question on this, like why there's a -1 here, I also needed some explaining about it too, but it's really simple. It's just that like in computer science or programming, you do everything with respect to an index of 0, right? Your starting index is 0, 1, 2, 3, 4, 5, 6, right? But in like real life, when you go to a restaurant like McDonald's, you'll see that they don't have like an item 0 on the menu. So so basically you're trying to specify here that your users will say something like, hey, I want item 5, or sorry, I'll give you a better example. Hey, I want item 1. That means you want to access index 0. And because of that shift in the beginning of it, that shift goes all the way throughout. So if they're trying to access item 5, your program has to interpret it as item 4. All right. I guess that's it in terms of explaining. We're going to have a public Google Doc or some sort of publicly accessible content that contains a leaderboard for all of you guys who have detected errors. So basically, what I want you guys to do is look through this and try to fix as many errors as you can during a given day, and then basically just like submit all the errors that you found, or the count of errors. But you can't just submit like a raw count of errors. I want you guys to like take some time to like detailed explaining each one. And you might ask, why are we doing this really weird abstract concept? You'll realize that you guys pretty much should have all the knowledge down. We've provided everything that you need to pick up. The only thing now, and it's a thing that you guys I know approached us a lot in the beginning, is you have all these errors in your code and you can't figure out what they are without having to ask someone else, right? This should be able to kind of exercise that process. I'm trying to give you guys some bad code to fix. So yeah, I'm hoping this should be like a really good learning experience for you guys. Do you have any questions? It's a pretty big project, so go ahead and fire a lot of questions if you have them, because I want as many of you guys to try this as possible. Sai, is there anything else you wanted to add about like details on how they should submit their?
Yeah, so I'll be sending out a Google form or like some kind of form right after the meeting. So basically, for each and every individual thing that you found as an error, or I guess anything that you think is an error that you fixed, you should submit a like a post, right? I mean, you should submit an entry to the form, and for each entry, you're gonna describe the line number where it is. You're gonna tell us the line numbers, and then you're gonna give us like a small paragraph, like 2 to 3 sentences about what the error was and what you did to fix it. So that way we know that yes, you have found an actual error, and yes, you actually know what you're talking about. Right. So based off of how many errors you fixed, and we're not going to tell you how many there are, but there's a lot. But when you fix it based off how many errors you fixed, that's going to give us our leaderboard. So the people who win this challenge are going to be the person who fixes the most issues. Then if there's a tie, it's going to be whoever did the issues the earliest, so whoever was quicker. And then beyond that, I guess we'll look at code neatness or something else. But the two main things are going to be how many issues did you fix, and then if there's a tie, how fast did you do them? And we'll do a leaderboard, and then we'll go over it on Tuesday.
Yeah, remember your explanations are probably the most important part. We're not going to validate some of your errors if they're not explained well. Now, I'm not saying like write common app application 650 words essay for each error that you find, but I'm just saying like you have to be direct. You can't just say, oh, this thing looks sus, I don't know about it, right? You have to be very specific, like, hey, this line is missing a semicolon, or you're trying to make a static reference to something that's not static, things like that. If you can speak in those technical terms, then you should be able to make it short. However, if you struggle to, you might realize that you talk a little bit longer than you need to, but that's still fine as long as you're getting the right point across. That's what matters. That's how you communicate in the real world, by the way. I think it's a really good concept, like breaking exercise. Like when you're working with a lot of your teammates, right? You'll come across a lot of errors, and a lot of them won't listen to you in terms of like fixing it if they're not understanding what the true problem is. So your ability to detect and also explain to others the area that you found is something that's really important to carry on with you with all walks of life.
Yeah, so overall, you're going to find that as you get older and as you get more experienced, a lot of what you do is actually going to be just fixing errors, right? More than actually writing your own code, the hardest part about programming is often just fixing the errors and like finding the small bugs that keep your program from working and running. So like this is like a really important exercise in that it teaches you those skills of thinking critically and looking at your code and trying to understand other people's code, right? If you write a piece of code, it's really easy to know what you're trying to do because you wrote it. But often in life, as you gain more seniority, a lot of what you're going to do is going to be looking at other people's code and trying to understand it. So I think this is a really good exercise in terms of that. And obviously, we're trying to make it a bit more fun with the leaderboard and the competition. But yeah, so this is a really important exercise, and we highly, highly, highly encourage that you take this seriously and you take some time out and actually try and do it.
Yeah, so although the leaderboard will be something that's there to kind of keep it a little bit suspenseful for you guys and kind of give a more competition sort of layout, we will tell you that like the people who are on the upper part of the leaderboard, or at least me and Sai will have read a lot of your content, and if that's good stuff, that means people who are on the top of the leaderboard are probably in good terms to join the programming team. So don't think like it's sort of an optional thing if you're trying to get into the FRC programming team. Of course, for you guys in FTC, this is really just a nice little challenge for you. You can still be on the leaderboards or whatever. It's still fun in that sense, but
No, but let me see if I can help. For the Frog Force guys, the guys who want to be on the programming team, this is kind of mandatory. You need to do this. If you can't solve this simple problem, then it's going to be really hard for you to try and help us build the robot code that we need to build to compete. So this is kind of a test. See how you guys do. You know, we wrote all the code for you. I think it's an excellent example, excellent exercise.
yeah.
You need to go through it and try and fix it.
Yeah. Although, yeah, it is definitely mandatory. However, never don't beat yourself up over it if you can't find more than 2 errors. Like the way that the group selections work will be more like relativity based rather than like anything more than that. So like just try. As long as you try your best, you should be able to succeed, to be honest. Like don't think like you have to get 100% is basically what I'm saying to get in. It's not like some strict cutoff score that we're looking for. We're trying to pursue like talent and just like clear work ethic, I guess.
Yeah, basically, if you know what you're doing and you've really been paying attention throughout all these, I guess, 6 or 7 classes that we've held now, if you've paid attention in every class and you did the exercises, you should be in good shape to be able to find most of the issues in this code.
Alright.
So don't think that we've given you like some impossible task and we want you to fail and we're trying to fail you. That is not what's going on.
Yeah, it's not.
Yeah, but if you've paid attention, you should be able to find most, if not all, of the issues in this code, and that proves to yourself and proves it to us that you know what you're doing, and that
Yeah.
you're gonna be successful come build season.
Yeah, some of these are really hard. So like I'm telling you right now, I know that maybe some like 1-year experienced programmers might still struggle to detect a few of these. It's like I'm calling out specifically like the logic ones. But yeah, so that's why I'm saying don't beat yourself up over it. Like it's not the end of the world. Yeah, okay. Are there seriously no questions though on like at least the problem? I feel like the problem should have a little bit of questions. Like, are you guys 100% understanding of like what the overall problem statement is?
Or I guess raise your hands if you're planning to participate. Okay, I see 3 people. I see 5, 6, 7, 8.
If your hand's not raised, you're not on the program.
9, 10, 11, 12, 13, 14, 15, 16, 17.
Raise your hand.
There's a hand icon at the bottom of your screen in Teams. Like I see like 17 people right now. And I don't know, that there's 40 people on this call, so far less than half.
I'm on my iPad and I don't see like a hand button.
I think that's fine. We're
it's
mainly
okay.
using it to just get a rough number.
And
Yeah,
see,
we're
really.
trying to pressure you guys. It's
Yeah.
it's really something that we want you to try out. All right. So
Yeah, so I see so far I only see 16 or 17 future programmers out of the 40 people here. Okay, now it's 19.
okay.
Yep.
Some people are probably just not knowing how to raise the hand, or
Yeah. Don't worry about it. It's just a little gig for you guys.
Yeah.
So yeah.
Yeah,
make
but
sure
I
to
guess
give it a shot.
at least we know that you're awake.
Yeah.
Yeah.
It's really hard to do this kind of stuff when, like as Mr. Moore says, all you hear is crickets. So yeah, just to make sure you're following along. Okay.
This is the first time we actually had some life out of anybody.
Yeah.
Wow, this is great.
Maybe we should make everything dependent on their programming team
Really?
membership. Yeah, Sai, could you lower all the hands now? So just so that
So everyone, you can lower your hands.
yeah, just in case someone has a question. If your hand is still raised, I'm gonna call you out.
Your
and
hand
ask
is
what-
still, yeah.
Josh, your hand is raised. Do you have a
Okay,
question?
I see
Yeah.
Nihita has her hand raised. Okay, that's gone. Shujan has.
Okay,
Okay.
John's gone. Okay, yeah, no one has
Yes.
their hand raised. All right, great. I saw a lot of questions in chat earlier about viewing some code. Was that resolved, Sai?
Okay. I guess.
Are any of you
A
still
lot
looking
of
for the
people
code?
type E instead of raising their hand, but yeah.
All right, yeah, it's fine. I guess I have to keep doing that. Yeah. So then, I think we're set. Then we'll have it sent out, including the link to this. Oh, by the way, you're not going to be able to edit this directly because this is on our FrogForce Repel. So when you're accessing it from a different account, I think you guys can still see my screen. But yeah, if you're accessing it from like another account, all you have to do is like type just like anything, like essentially like show intent to make a change, and Repel will already it will automatically detect, oh, he's trying to make a change, but he's not allowed to edit this document. So I think it will automatically create a copy of the Repel for you. If not, I think there should be an easy way of making a copy of it. Yeah, no, I think that's the only
I think
way.
we
That's
should
the way that we did
just.
class.
I think we should just send the 3 files in an email, and I think then they can just like.
Yeah. So I mean, we'll figure out how to get this to you like later tonight. We'll send you the link to this and the link to the form, and then once that email is sent out, you're on the clock. So
Yeah,
let's
and
see
you have.
who's fastest.
How long did we decide that they would have to submit all of these?
You have till before the class starts on Tuesday. All right. Once the class starts, the leaderboard is leaderboard, and the challenge is over. So 5:30 on Tuesday is your deadline. Let's see how many you can figure out by time by then.
So look out for the email. It will have the code and how you submit the bug fixes. So be on the lookout for that email and read it carefully.
Yeah, good luck, guys.
Yep. So if there's no questions, you guys are free to leave, and good luck. And we'll see how you guys do.
Thank you.